Welcome to lesson 3B on rate of reaction. Here, as we look at the effect of temperature, we want to consider the graphical method whereby we are going to look at a practical, see how to get data, use that data to come up with a graph, and then use that graph to obtain necessary information. We will look at a typical practical where we are going to react magnesium ribbon with hydrochloric acid. Typically, you might be provided with a length of magnesium ribbon, which you will be required to cut into equal pieces. So in this case, we're talking of 5 pieces of 2 centimeters each. And then you will add each piece to an amount of hydrochloric acid in separate reaction vessels. Maybe point to note is that here we have used conical flasks because I'm considering it will be easier to put the conical flasks to heat over a tripod. But then in other circumstances, you might heat over a water bath, and in that case, you'll be provided with test tubes or boiling tubes for the same. Let us note certain points before we proceed. You've noticed that we are cutting the magnesium ribbon into equal pieces. And so, what we are trying to do is to ensure that the magnesium ribbons are of equal mass, and then the same volume and concentration of hydrochloric acid is also used, that being 50 cubic centimeters of 1.5 molar. So in essence, the mass of magnesium ribbon is kept constant, and also the number of particles inside hydrochloric acid is also kept constant. The only thing that we seek to vary in this experiment is the temperature of hydrochloric acid. Proceeding with our procedure, you'll then take a piece of magnesium ribbon and put in the conical flask that contains hydrochloric acid at room temperature, which we take to be about 25 degrees Celsius. Then you'll note the time it takes for that piece to disappear. I've given a digital reading of what you might see on your stopwatch when you carry out the procedure. Then you will heat the second conical flask to this time 30 degrees Celsius, so we have varied the temperature, but we are still putting in the same mass of magnesium ribbon in the same concentration of hydrochloric acid, and let's say that that is the other reading that we get. So we'll repeat this procedure with all the other flasks, only that now we vary the temperatures to 40 degrees Celsius for the third one, then 50 degrees Celsius for the fourth one, and 60 degrees Celsius for the fifth one. Now, how then do we relate our results, or how do we manipulate this data? Normally, you'll be provided with a table, and since it is temperature that we are varying, the table will already have filled out values for temperature, so that all you have to do is slot in the time recorded for the magnesium ribbon to disappear. Now I want us to note that the time here is in seconds. Specifically, I have given these digital stopwatch readings so that then we see what is expected of us whenever we are tabulating such results. It is advisable that always your time readings in seconds should be in whole numbers. So if you're to read the time taken for the magnesium ribbon to disappear when the temperature was 25 degrees Celsius, what we'll then have is at 25, it was the 005384, but as a whole number will just indicate that that was 53 seconds. Don't mind the other digits so that you feel that because they are above 50, then you need to round off this to the next figure. Just give that reading that you have seen on the seconds as it is. At 30, then we will say that our reading is 18 seconds. At 40, we will then say our reading is 12 seconds. At 50, we will then say our reading is 10 seconds. And at 60, we will say our reading is 9 seconds. We are then supposed to use these figures to plot a graph, and this is how we go about it. When you're given your grid, of course, you must have your X and Y values. Now, because the temperature is the one that was being varied in this experiment, then we have that on our Y-axis or the vertical axis. And then the time we'll record on our X-axis or what we call the horizontal axis. So in that case, we have to choose scale that is going to ensure that our curve is covering at least 3/4 of the grid. So in that case, let's just try that on our Y-axis we have 0 to 60 because our maximum temperature is 60. And then because our time is also ranging from 53 to 9, well, we can still use a 0 to 60 to see how well that takes us. So our X-axis will also have a 0 up to 60. Now in this case, we can see that when the temperature is low, the time is a lot or high, and when the temperature is high, the time is little. So in that case, as we are looking at our X values, which is the time, then it seems we will have to start from the right hand side, plotting right hand side coming towards left hand, so that in the first instance we'll see that when the time is 9 seconds, then the temperature reads 60 degrees. So where the two lines cross each other, that's when we have our first plot. Again, when the time is 10 seconds and the temperature reads 50, we can see that at that point of intersection, that is where we're supposed to put our plot. So going by that, then we'll have it that at 12, we are going to have a temperature of 40. At 18 seconds, then that's when we get to temperature of 30. And lastly, at 53 seconds, then we have our temperature of 25. We are then supposed to have that as a smooth curve following as so. And that's the way we plot the graph for temperature against time.